Greetings everyone. Today we will discuss about the angular momentum and moment of inertia. Angular momentum. Angular momentum is the vector cross product of translational momentum and the displacement of that momentum relative to a fixed point. Angular momentum is denoted by capital L and that is equal to R cross P. P is the linear momentum here. Since angular momentum is a vector cross product, its direction follows the right hand rule. Now let's discuss relationship between torque and angular momentum.
See the relationship between torque and angular momentum. As torque is R cross F and angular momentum is R cross P. Here P is linear momentum. So this is equation number 1 and 2. Now differentiate equation 2 with respect to t. That is dl divided by dt is equal to d by dt r cross p. Now apply the product rule here. Our first vector say dp by dt plus differentiate of first vector dr by dt multiplied by p. See here, change in momentum with respect to time is equal to the external force according to Newton's second law plus dr by dt is velocity cross p. You can write r cross f plus v. As we know, momentum is mass multiplied by velocity. See here, R cross F plus I can write here V cross V and see here dl by dt is equal to R cross F is torque plus cross product of same quantity is 0. V cross V is 0. Therefore, this external torque is equal to change in angular momentum with respect to time. This is the relationship between the torque and angular momentum.
Now see moment of inertia. In physics, moment of inertia is a quantity expressing a body's tendency to resist angular acceleration, which is the sum of the products of the mass of each particle in the body with the square of its distance from the axis of rotation. Moment of inertia is denoted by capital I and that is equal to the product of mass, that is m, and square of distances from the axis of rotation, that is r square. Now, expression of moment of inertia.
See, moment of inertia. Consider a rigid body rotating with uniform angular velocity, say omega. About this y dash axis of rotation. Suppose the body consists of n particles of masses m1, m2, m3 up to mn respectively, situated at a distances r1, r2, r3 up to rn respectively from this axis of rotation. Then moment of inertia of the body, inertia is denoted by I, and we know inertia is the product of mass and the square of distance from the axis of rotation. So for first particle, inertia is m1 r1 square. For second particle, m2 r2 square. For third particle, m3 r3 square plus up to mn rn square. So we can write inertia as summation of I is equal to 1 to n. For n particles I am writing mi ri square. And we all know what are the dimensions of inertia. You can write dimensions. See, dimensions for inertia: mass m, for distance L square, time is 0. These are the dimensions of moment of inertia. Then what is the SI unit? SI unit is kg meter square.
That's all. Thank you.